In a single recycling facility in Chile, more than 500 tons of copper are recovered daily from scrap that would be discarded as waste. Giant furnaces reach temperatures of 1200 degrees Celsius, melting old electrical wires, abandoned pipes, and discarded electronic components, transforming them into pure copper ingots worth more than $8 million per day. But here's the billion-dollar secret the industry doesn't want you to know. The global copper market moves $350 billion annually, and 40% of that astronomical value comes from recycled materials. That means $140 billion in wealth is literally extracted from what we consider trash. The device you're using to watch this video, whether smartphone, tablet, or computer, contains between 15 and 100 grams of recycled copper, representing a small fraction of the $2 trillion that the global electronics industry moves using this precious metal. The photovoltaic industry alone consumes recycled copper worth $45 billion annually to manufacture solar panels that power the global energy revolution. Each solar panel contains 4 kilograms of copper, and with 100 million panels installed globally each year, we're talking about 400,000 tons of copper, mainly recycled, worth more than many countries' GDP. The sound is hypnotizing. The roar of giant machines crushing tons of electronic scrap worth millions. The rumble of furnaces melting metal at volcanic temperatures to create ingots that will feed billion-dollar industries. And the hiss of liquid copper being molded into bars that will sustain entire economies. In 24 hours, a single recycling plant processes scrap worth $20 million, enough to build the electrical infrastructure of an entire city. How is it possible that discarded materials become the foundation of a trillion-dollar economy? How does recycled copper secretly power everything from your smartphone screen to wind turbines that generate clean energy? And why could this resurrected metal determine who will control the $500 billion of the renewable energy economy? The answer is hidden in mega recycling facilities. Industrial cathedrals where modern alchemy transforms electronic waste into billion-dollar treasure, creating a secret economic cycle that literally sustains modern digital and energy civilization. The history of copper recycling began more than 4,000 years ago, when ancient civilizations discovered they could melt damaged bronze objects to create new utensils. But it was only in the 20th century that this process transformed into the billion-dollar money machine we know today. The Romans were the first to establish an organized metal recovery system, collecting weapons and tools from battlefields to reforge into new military equipment. Without knowing it, they created the first circular economy model that today moves hundreds of billions of dollars. The true economic revolution came during the Industrial Revolution when copper demand exploded with the invention of telegraph and electricity. In 1860, the first commercial recycling foundry was established in Birmingham, England, processing scrap from textile factories and railways. What began as a business of thousands of pounds would transform into today's hundreds of billions of dollars industry. World War I transformed copper recycling from marginal business to billion-dollar strategic necessity. Governments invested the equivalent of 10 billion current dollars in recycling infrastructure, requisitioning pots, pipes, and even church bells to produce ammunition and military equipment. Patriotic campaigns moved the equivalent of $5 billion in recycled copper. The 1920s brought innovations that created the first billion-dollar recycling industry. The invention of electromagnetic separation allowed automatic processing of mixed scrap, increasing processed value from millions to billions of dollars annually. The Great Western Smelting Company developed the first continuous refining process, creating an operation that today would be worth $50 billion. World War II massively accelerated the recycling economy. Converted factories processed the equivalent of 100 billion current dollars in scrap, developing techniques that would sustain the modern electronics economy. The American Victory Scrap program moved the equivalent of $200 billion in recycled metals. The modern digital era exploded in the 1970s when the electronics industry created insatiable demand for ultra-pure copper. Today, just the smartphone industry consumes recycled copper worth $25 billion annually, while the global copper recycling industry moves $350 billion, more than South Africa's GDP. The process of transforming scrap into pure copper is a billion-dollar operation that begins with strategic collection of materials worth fortunes. Specialized trucks traverse cities collecting electrical cables from demolitions, $20 per kilogram. Discarded electronic components, up to $50 per kilogram in precious metals, and renovation pipes, $8 per kilogram. Each load represents between $50,000 and $200,000 in recoverable value. Initial sorting happens in giant yards where magnetic separation machines process materials worth $5 million daily. Eddy current systems separate aluminum, $2,000 per ton, from copper, $9,000 per ton, while specialized workers identify special alloys that can be worth up to $20,000 per ton. Mechanical processing uses $5 million industrial shredders that reduce thick cables to precise fragments. Density separation systems, costing $10 million each, concentrate copper to purity above 95%, increasing value from $8,000 to $12,000 per ton. Pyrometallurgy is where billions of dollars are literally melted and recreated. $50 million reverberatory furnaces reach 1,200 degrees Celsius, processing liquid baths of 500 tons worth $4.5 million each. $20 million oxygen injection systems remove impurities, transforming copper from $8,000 per ton to copper blister at $9,500 per ton. Electrolytic refining is the final money machine of this billion-dollar operation. $100 million electrolytic systems process currents of 15,000 amperes, dissolving impure copper and depositing pure copper worth $10,500 per ton. As a billion-dollar bonus, impurities like gold, $60,000 per kilogram, silver, $800 per kilogram, and platinum, $30,000 per kilogram, accumulate as anodic slime that can be worth more than the copper itself. A single modern plant processes 100,000 tons annually, generating revenue of $1 billion and profit of $300 million, demonstrating why this industry attracts billion-dollar global investments. Modern copper recycling facilities are true billion-dollar machines that incorporate cutting-edge technologies to maximize every dollar extracted from scrap. $50 million artificial intelligence systems analyze composition through X-ray spectroscopy, automatically identifying alloys that can be worth between $5,000 and $20,000 per ton with 99.8% precision. $10 million separation robots each, equipped with computer vision, process 10 tons of electronic scrap per hour, material worth up to $500,000 per ton in precious metals. These robots distinguish between different types of electronic components. Motherboards, $15,000 per ton. Processors, $20,000 per ton. And gold-plated connectors, $100,000 per ton. $20 million thermal plasma technology revolutionized processing for the billion-dollar electronics industry. Plasma torches at 15,000 degrees Celsius process discarded smartphones, each containing $15 in copper and precious metals, recovering 98% of value. With 2 billion smartphones discarded annually, this represents $30 billion in recoverable value. State-of-the-art induction furnaces costing $80 million operate with efficiency that saves $20 million annually in energy. Computer-controlled magnetic fields separate metals by melting point, allowing simultaneous recovery of copper, $10,000 per ton, aluminum, $2,000 per ton, and precious metals. $40 million advanced hydrometallurgy uses specific chemical solutions to extract copper from circuit boards, a process that transforms electronic scrap from $1,000 per ton to pure copper at $10,000 per ton. Solvent extraction systems purify solutions, recovering even rare metals like indium, $600 per kilogram, and gallium, $300 per kilogram. The device you use to watch this video went through these same billion-dollar processes. Your smartphone contains recycled copper that was once part of telephone cables from the 80s. computers from the 90s, and electronic boards from industrial equipment. This infinite recycling cycle sustains the $2 trillion electronics industry that defines our digital age. Quality control in copper recycling is more rigorous than Fort Knox, as each processed batch is worth millions of dollars and feeds billion-dollar industries that tolerate no imperfections. $5 million laboratories equipped with optical emission spectrometers analyze chemical composition of each batch, detecting impurities that could devalue a ton from $10,500 to just $5,000. Electrical conductivity tests verify that recycled copper maintains properties that sustain the $2 trillion electronics industry. Samples are subjected to currents of 1,000 amperes to measure specific resistance. Any deviation can mean loss of millions in contracts with smartphone, computer, and telecommunications equipment manufacturers that demand copper with perfect conductivity. Metallographic analysis through $2 million electron microscopes examines crystal structure, revealing defects that could compromise applications in the $200 billion photovoltaic industry. Solar panels demand copper with absolute purity. A defective batch can cost $50 million in recalls and reputation damage. Mechanical fatigue tests subject recycled copper wires to millions of cycles, simulating decades of use in applications worth trillions. Electrical cables for the $150 billion wind industry must withstand 20 years of operation without failures. A defective cable can bring down a $3 million turbine. International certification through organizations like ASTM and IEC guarantees access to billion-dollar global markets. A certification can be worth $100 million in contracts, while its loss can ban a company from entire markets. Quarterly audits cost $500,000 each but guarantee access to industries that move trillions. The copper powering the device in your hands passed through all these billion-dollar tests. Every gram was analyzed, tested, and certified to ensure your screen works perfectly, your battery charges efficiently, and circuits transmit data at light speed, all sustained by a recycling industry that transforms waste into quality standards worth fortunes. Copper recycling is not just environmentally responsible. It's a billion-dollar machine that's redefining the global economy. Each ton of recycled copper avoids environmental costs of $15,000, extraction of 200 tons of ore, water treatment, environmental restoration, transforming sustainability into direct profit for an industry that moves $350 billion annually. The renewable energy industry, valued at $500 billion, fundamentally depends on recycled copper for its economic viability. Each $3 million wind turbine uses 5 tons of copper, 80% recycled, saving $25,000 per turbine. With 100,000 turbines installed annually, this represents $2.5 billion in direct savings. $100 million carbon capture technologies transform emissions into sellable products, creating additional revenue of $10 million annually per plant. Chemical absorption systems capture CO2 from furnace gases, converting it to carbonates sold for $300 per ton to the $2 trillion chemical industry. Recovery of precious metals from anodic slime represents a parallel billion-dollar business. Each ton of recycled copper produces 400 grams of silver, $320, 15 grams of gold, $900, and traces of platinum, $450. A plant processing 100,000 tons annually generates $40 million, additionally just in precious metals. The $2 trillion electronics industry is redesigning products to maximize recyclability. Collaborations resulted in smartphones that facilitate material recovery, increasing recoverable value from $15 to $25 per device. With 2 billion devices discarded annually, this represents $20 billion additional in recoverable value. Your current device is part of this billion-dollar circular economy. The copper in your screen, battery, and circuits has been recycled multiple times, generating economic value with each cycle. When you eventually discard this device, it will feed the next generation of technology, keeping alive a cycle that sustains trillions of dollars in global economic activity. The biggest billion-dollar challenge in copper recycling was the cross-contamination problem. Different mixed alloys created products that lost up to 50% of market value. A ton of pure copper is worth $10,500, but contaminated is worth only $5,000. A difference that cost the industry $5 billion annually in lost value. The $100 million solution came through portable X-ray spectrometry that identifies exact composition in seconds. This technology transformed operations that lost billions into operations that maximize every dollar, allowing precise separation that recovers 98% of potential value from each batch. The issue of miniaturized electronics almost cost the industry access to the $25 billion annually from smartphone recycling. Development of $50 million robotic techniques and ultrasonic selective dissolution allowed recovery of copper from microscopic components, increasing recoverable value from $15 to $25 per device. Extreme copper price fluctuations, from $5,000 to $15,000 per ton, created instability that threatened billion-dollar investments. Futures contracts and financial hedging stabilized revenues, while diversification to other metals, aluminum at $2,000 per ton, zinc at $3,000 per ton, reduced risks and created additional revenue streams of $40 billion. Environmental regulations required $200 million investments in emissions control, but created $5 billion competitive advantage. Certified plants access premium markets that pay up to 20% more for green copper, transforming environmental costs into economic advantage. Skilled labor shortage threatened billion-dollar operations. $10 million training programs in partnership with universities created specialized workforce, while $20 million AI systems assist operators, increasing productivity by 30% and generating $100 million additional in annual revenue. Each overcome challenge transformed the industry into a more efficient billion-generating machine, proving that technological innovation and environmental sustainability can create astronomical economic value. Recycled copper secretly powers the billion-dollar renewable energy revolution that's redefining the global economy. The $200 billion photovoltaic industry consumes recycled copper worth $45 billion annually. Each $500 solar panel contains $20 in recycled copper. With 100 million panels installed annually, we're talking about $2 billion just in recycled copper for solar energy. The $150 billion wind industry depends massively on recycled copper. Each $3 million turbine uses 5 tons of copper, $40,000, 80% recycled. With 50,000 turbines installed annually, this represents $1,600 million in recycled copper sustaining the global energy transition. The $2 trillion automotive industry consumes recycled copper worth $80 billion annually. Electric vehicles, a $500 billion market, use 4 times more copper than conventional cars. A $100,000 Tesla Model S contains $850 in recycled copper, while $50,000 fast-charging stations each use $2,000 in ultra-pure copper cables. The device you use to watch this video represents a fraction of the $2 trillion of the global electronics industry sustained by recycled copper. Your $1,000 smartphone contains $15 in recycled copper. Your $2,000 laptop contains $40, while the data center transmitting this video uses millions of dollars in recycled copper cables for high-speed connections. The $1,500 billion telecommunications infrastructure would be impossible without recycled copper. $200,000 cell towers each consume $10,000 in copper for grounding and distribution. Submarine fiber optic cables, each kilometer costing $100,000, use recycled copper wires for power along oceanic distances. Civil construction consumes recycled copper worth $90 billion annually. A $300,000 house uses $3,000 in recycled copper pipes and wiring, while $500 million skyscrapers can consume $5 million in electrical systems based on recycled copper. High-tech medical applications demand ultra-pure copper frequently obtained through controlled recycling. $3 million MRI equipment uses $100,000 in super-pure copper coils, while the $4 trillion global medical industry depends on devices incorporating recycled copper for sterilization and conductivity. Every touch on your device screen, every battery charge, every internet connection is possible thanks to a billion-dollar network of recycled copper that connects and powers our digital civilization. The billion-dollar future of copper recycling is being revolutionized by technologies that will transform trillions of dollars in recoverable value. $500 million quantum artificial intelligence will optimize molecular separation processes, allowing recovery of 99.99% of copper present in any material. Technology that can add $50 billion annually in global recoverable value. $1 billion nanotechnology will enable atomic-scale recycling. Programmed nanobots will extract copper atoms from composite materials, enabling recycling of products that today represent $100 billion in annually lost value. This technology will make it possible to recycle copper from conductive paints, ultra-diluted alloys, and even biological components. $2 billion biotechnology will develop microorganisms that concentrate copper from diluted solutions. Specialized bacteria will extract copper from seawater, a resource containing 4 billion tons of dissolved copper worth $40 trillion, creating completely new sources of recyclable material. Nuclear fusion will provide clean energy for recycling processes, reducing energy costs by 80% and adding $20 billion annually in profit margin. $100 million compact fusion reactors will allow plant operation anywhere, eliminating transport costs that today consume 10% of industry revenue. Three-dimensional printing with recycled copper will create a $500 billion market in on-demand products. $50 million industrial printers will use ultra-fine copper powder to create components for aerospace, $100 billion, automotive, $2 trillion, and electronics, $2 trillion industries. The space economy will create $1 trillion demand for recycled copper. Asteroid mining will provide quantities worth quintillions of dollars, but will need processing in $10 billion orbital stations each. Microgravity recycling technologies will enable superior purification, creating space copper worth $100,000 per ton. The device you use today is just the beginning. Future technology generations will consume trillions of dollars in recycled copper for quantum computing, advanced artificial intelligence, and brain-computer interfaces, all depending on the same billion-dollar industry that transforms your discarded smartphone into tomorrow's technology. The extraordinary journey of recycled copper, from discarded scrap to components that power a trillion-dollar economy, represents the greatest value transformation in modern industrial history. What began as economic necessity during world wars evolved into a $350 billion industry that secretly sustains everything from the device in your hands to wind turbines generating clean energy. Each copper ingot emerging from these billion-dollar facilities carries decades of technological history and trillions of dollars in future economic value. The process that transforms your old smartphone into components for solar panels, wind turbines, and the next generation of electronic devices is a testament to humanity's capacity to create astronomical value from what others consider waste. The technological complexity of modern recycling plants, hundreds of millions of dollars in investments in robots that identify valuable materials in milliseconds, furnaces operating at volcanic temperatures, processing millions of dollars in liquid metal, demonstrates how the pursuit of sustainability can generate innovations that create trillions in economic value. Recycled copper is not just a recovered material, it's the invisible life force of a trillion-dollar circular economy, the element that allows our technological civilization to continue growing without depleting natural resources. Every touch on your device screen, every battery charge, every internet connection is possible thanks to this billion-dollar industry that transforms waste into digital prosperity. The impact of this industry transcends astronomical economic numbers, touching fundamental aspects that will define who controls the $500 billion of the renewable energy economy, the $2 trillion of the electronics industry, and the trillions of dollars of the future space economy. Copper's infinite recyclability positions it as a key element for a future where sustainability and economic prosperity unite in billion-dollar synergy. How incredible to discover that the device in your hands is part of a billion-dollar economy that transforms waste into treasure. The next time you discard an old cable, replace a smartphone, or renovate house wiring, remember you're feeding a $350 billion industry that secretly sustains everything from solar panels to wind turbines. What impressed you most in this exploration of the billion-dollar recycled copper economy? Was it discovering that your device contains copper that once powered entire cities? That the $500 billion renewable energy industry depends on recycled materials? Or perhaps that each discarded smartphone is worth $25 in recoverable materials? Leave your comment below and share from where you're watching. Your comment is very important so we can always bring new videos about how the things we know are made and that we often don't know how they're produced. Share the video with your friends and family, and don't forget to subscribe to the channel. Do you know someone who works with recycling, electronics, renewable energy, or who simply fascinates with the billion-dollar processes that shape our economy? Share this video and help spread knowledge about the invisible industries that move trillions of dollars sustaining our modern life. And if you're curious to discover more secrets of the billion-dollar circular economy, don't forget to subscribe to the Factory Made channel, where each episode reveals the hidden processes that move trillions of dollars in the world. What other billion-dollar materials would you like to see unveiled? Aluminum recycling that sustains the automotive industry? Recovery of rare earths that feeds the technological revolution? Or perhaps the precious metals that make the digital age possible? Your curiosity could be the next billion-dollar episode we explore together in this fascinating journey through the world of industrial processes that secretly govern trillions of dollars of the global economy. Special thanks to Arubis, Glencore Recycling, Boliden, and Umicore companies, billion-dollar giants that move hundreds of billions of dollars annually, for making available technical materials and access to their industrial operations that made possible this detailed exploration of the billion-dollar economy of copper recycling. Gratitude also to metallurgical engineers, sustainability specialists, and economic analysts who dedicate their careers to improving processes that move trillions of dollars globally. We thank circular economy research institutes and technical universities that share knowledge about metal recycling and billion-dollar economic impact, contributing to scientific advances that benefit industries worth trillions of dollars. Special recognition to recycling plant workers around the world, who operate million-dollar equipment in challenging conditions to process the billions of dollars in materials that secretly feed our trillion-dollar global economy, demonstrating dedication and expertise that make our sustainable technological society possible. And, most importantly, our sincere thanks to you, who dedicated your time to follow another exploration of the factory-made universe. Your curiosity and interest are the fuel that motivates us to continue unveiling the secrets behind the billion-dollar industrial processes that shape our trillion-dollar economy and our technological future. Continue with us on this journey of billion-dollar discoveries. Explore our other videos about industrial processes and discover how seemingly simple materials hide operations of complexity and economic importance that move trillions of dollars. At Factory Made, each story is a celebration of human ingenuity and the magic of industrial transformation that creates billion-dollar value. Research and script by Factory Made team, transforming curiosity into knowledge, $1 billion industrial process at a time. The next time you hold your electronic device or see a solar panel, remember the incredible billion-dollar economic journey that transformed discarded scrap into the materials that secretly feed and sustain trillions of dollars of our modern technological civilization.